revision. In this class, we'll be talking about indices. I said indices. Alright, indices. You must have heard of indices before now, or if you are hearing for the first time, congratulations. Indices is the power to which a number is raised. I said this is the power to which a number is raised. Look at this. A raised to power x. Now x here is our power. Or you can call it index. Okay, I said it is power or index. While A here is our base. Can I say that again? I said base. You must have seen such example as 100. Okay, you wonder how do we divide 100? How do we break 100? How do we split 100 in tens? And it is 10 by 10. 10 multiplied by 10. Okay, and that is equivalent to 10 raised to the power of 2. This is the index form of 100. I said it is the index form of 100. So I can say 2 here is our power, while 10 here, okay, it's our base. Alright, same thing applies for 4. 4 can be split to 2 multiplied by 2, where you have 2 raised to the power of 2. 8, 16, you know the likes, that's 2 multiplied by 2 multiplied by 2, pardon, okay, multiplied by 2 multiplied by 2, and that gives us 2 raised to the power of 4. The 4 here is what I call the what? The index or power, while the 2 here is the base. Okay, in respect to this, I'll teach you 9 laws of indices. How many laws did I say? 9 laws. Okay, 9 laws. 9 laws of indices. Alright, thank you very much for your attention. Just go along with me. The first law is called addition law. Okay, it is the addition law. It is the addition law. And what's the addition law saying? Addition law states that when you have A raised to the power of m multiplied by A raised to the power of n, then you have A raised to the power of m plus n. What has transpired here? Look gently. A, same base, mn, different power. Alright, when you have same base, different power, what do you get? Pick one base, or you select one base, and the multiplication sign here changes to positive, which is m plus n. So A raised to the power of m plus n. So this makes it the addition law. The addition law. Alright, can we have examples? Revision examples. Okay, revision questions. Under this law, we have 6 examples. The first one here, okay, it's x raised to the power of 7 multiplied by x raised to the power of 5. The second, is 5 raised to the power of 8 multiplied by 5 raised to the power of 4. These are examples that we want to do. Okay, we have 5 raised to the power of a, alright, and 4 raised to the power of this. Okay, and you have the fourth one as p minus 8 times p minus 4. And you have the fifth one known as a raised to the power of 5 multiplied by b raised to the power of 4. Then let's have the last one as 3 raised to the power of x, 3x raised to the power of 4 multiplied by, what do we use? We use 7y raised to the power of 5. Okay, these examples covers different aspects where you can get to know this law very well. Okay, let's move on. Alright, so let's move on the solutions of these 6 examples by revision series. Okay, let's move on. Solution. Okay, the first question here, x raised to the power of 7 multiplied by x raised to the power of 5. Now look here. I told you earlier that in our law, addition law, when you have the same base, and multiplication sign is in between them, just pick one. Okay, pick one. Then you add your powers. Same thing that happens here. X, select X, then 7. Okay, plus, okay, 5. And that's X raised to the power of 12. You get that. Select one of the common base, add your powers. 7 plus 5, that's 12. Of course, you could as well use the long process. Look at this. X raised to the power of 7, X, or X, multiplied by 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 X. 1, 2, 3, 4, 5, 6, 7. That's the expanded form of this. Then multiplied by X raised to the power of 5. X multiplied by X, multiplied by X, multiplied by X, multiplied by X. 1, 2, 3, 4, 5. This is multiplication, this is X, alright? Don't mix them together. Okay, you will see, you will agree with me that this method is cumbersome. By the time you now begin to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's X raised to the power of 12. Of course, we arrive at the same answer, but one is a bit technical and simple, while the other is, of course, cumbersome. So I would not advise you to follow this because of instances where you have X raised to the power of 20 multiplied by X raised to the power of 70. So we'll be left with the option of multiplying X in 20 places. Of course, that's absurd. So go back to your addition law for such, questions. So let's move on. The second example, 5 raised to the power of 8. Okay, 5 raised to the power of 8 multiplied by 5 raised to the power of 4. Watch this. Common base, different power. Even if it is the same power, one thing that is eminent and important is that they have a common, you said, base. Yes, so just select one. That's 8. Times change to what? Plus, thank you. 4, right? And this gives us 5 raised to the power of 12. As simple as that. You get what I'm saying? Let's move on to the third example. Okay, that's 5a4, right? Alright, question 3. 5a raised to the power of 4 multiplied by 4a raised to the power of 3. Now I want to be very attentive here. Okay, you will see that there's a big difference between 2 and 3. Let's go on. Look at this. 5a raised to the power of 4 multiplied by 4a raised to the power of minus 3. The first thing to do is separate the numbers from the letters. What am I saying? 5 here, 4 here. Since there is a multiplication sign, it does not affect them. Okay, just take this 5 by 4. It will not be 5 plus 4. So don't say 5 plus 4 because of this. No. So just say, so this is wrong. It should be 5 by 4. Alright, in a bracket then, collect this. A4 multiplied by a raised to the power of minus 3. Alright, then let's go ahead. 5 by 4. 4 times. That's 20. Okay? Then a raised to the power of 4. Remember our addition law. Once we have a common base, what do? The multiplication sign changes to addition. And here we have a raised to the power of 4 plus, now another difficulty. We have another sign here which is minus. What do? Introduce a bracket sign. Alright, minus 3. Look at this. Anytime you have two signs facing each other in mathematics, what you do automatically is to multiply. And I will remind you of your multiplication sign. Okay, look at this. Minus multiplied by minus. Minus multiplied by plus. Plus multiplied by minus. And plus multiplied by plus. Now look at this. Minus multiplied by minus is plus. That is, negative times negative give you, addition, positive. Minus multiplied by plus is minus. Plus multiplied by minus is minus. While plus multiplied by plus is plus. As a mathematics student, this should always be with you at all time. It should always be with you at all time. These signs are very important in mathematics. They are sign and notations that should be known. So I trust you will study this. Just put it on your head, rehearse it, before you know it is part of you. So that's what we apply here. This one. Okay, now bracket means multiplication, you should know. So plus and minus, what applies? Plus and minus. It becomes minus. Thank you. Very good. So this is 20a 4. Is that good? 4 as plus times minus gives you minus 3. Then you say 20a 4 minus 3 is 1. Okay, in mathematics also, when you have a raised to the power of 1, it means a in one place, and that's a. Okay, so here you have 20a. Now these are simple way of solving such situations. Remember this. So the fourth question, our solution here, p raised to the power of minus 8 multiplied by p raised to the power of minus 4. All right, let's move on. Select one, p. Okay, why do we select a p? Remember our law, addition law. The same base, select one. All right, so minus 8. Here we come again. Look at minus 4, because this changes to plus, and we have minus 4. So what should we introduce here? We said, good, the bracket sign. All right. So the parentheses must be introduced each time two signs are beside each other. All right, did you get that? I hope you do. Okay, so p minus 8 plus times minus. Can you guess that? Plus times minus. Check here. Plus times minus, and that's what? Minus. Good. All right. Minus what? 4. So here, minus 8 minus 4. Here you might have issues. Minus 8 minus 4. Just assume that you are owing your friend 8 naira, another person 4 naira. In total, that's what? 12 naira. Owing. So minus depicts owing. All right. So minus 8 minus 4. That's minus 12. All right. So that's our answer for this question. Let's move to the fifth one. Okay. A raised to the power of 5 multiplied by b raised to the power of 4. This is interesting. You can see that this is exceptional, different from the others. Okay, so what do we do here? Something is strange, something is fishy here. Did you see it? Look at a power 5, b power 4. What's wrong? Oh, you saw it. Different base. Okay, different base. But the law says that when you have the same base, then you select one. Now that you have a different base, what do you do? Now look at, never say a raised to the power of 5 plus 4. Never. Because you'll be asked, where is the b? Never. Never say b raised to the power of 5 plus 4. Never. You will be questioned, where is the a? Okay. And never say ab raised to the power of 5 plus 4. And that gives you ab raised to the power of 9. Never. They cannot combine. Okay. They have different sex. So it is wrong. So what do you say in essence? A raised to the power of 5. Multiplication joins everything together. Multiplication. In biology, you will know what multiplication is. Like multiplication joins everything together. All right. So it means we have a raised to the power of 5, b raised to the power of 4. Each of them retains their power without joints. Arithmetic. You don't join them. Okay. And you guess what? That's our answer. No more, no less. So never say this, and never say this. Once they have different base, give them their power respectively and let them exist independently. You get that? We will see more when we give you revision questions to solve. All right? Thank you very much as you are following me. Move on to the sixth example. 3 x raised to the power of 4 multiplied by 7. y raised to power of minus 5. Yes, look at this again. Compare this. This looks like one of the examples we did. Which of the examples? Yes, example 3. Okay, where you have a coefficient beside the base, the coefficient. So what do we do here? But the difference between this and this is what? Watch this. Alright, so a here, x here, a here, y here. What am I saying? A, same base. X, y, different base. That's the difference between these two questions. Alright, so you don't mix them together. What we do here is just in a short form, 3 and 7. Put them together. Okay, remember your brackets. It's a way of demarcating and making your work orderly. Alright, so x raised to the power of 4 multiplied by y raised to the power of 5. Do you see? That's the same step we took here, but you will see the difference now. Now 3 by 7, 3 times 7, that's 21. Alright, now x raised to the power of 4 times y raised to the power of minus 5. Don't be too fast. If you say x 4 plus minus 5, you are wrong. What about x, y 4 plus minus 5? You will be wrong. Okay, what about x, y 4 plus minus 5? As well, you will be wrong. Why? Simply because we have different bases, so they should exist independently. We have different bases, they should exist independently. Alright, so what do we do? X raised to the power of 4, y raised to the power of minus 5. No more, no less. You understand? And this gives us the answer to the sum. Did you understand? So never attempt to go through these methods. Alright, this is the utmost and important method. Okay, so let me recap. For law 1, you come back. Your law 1, a raised to the power of x, we said our indices is power, x is power or index, while a is the base. Okay, we talked about the first law, addition law. You look at the questions, do you see them? X is the power of 7, x is the power of 5. That's 7 plus 5 gives us 12. Did you get that? Don't go through that long method of x by x by x. It will exhaust you, okay? Just use your formula method. Number 2, 5, 8, 5, 4. Did you get? What do? The same law applies. Okay, then we came to number 3. We said multiply the coefficient of the powers. Multiply the coefficient of the powers. I mean, a. 5 for here. 5 is the coefficient of a raised to the power of 4. Alright, 5 is the coefficient. So 5 by 4. Then this a raised to the power of 4 multiplied by this. What did we do? We then say that you select 1, then you add this. Then here I told you about the introduction of brackets. Okay, when you introduce your bracket, it is to demarcate two near signs. Okay, thereafter I told you about your signs. Minus, minus, plus. Minus, plus, minus. Plus, minus gives you minus. Plus, plus gives you plus. This must always be on your mind every now and then in mathematics. Then we proceed. Minus times plus, minus 4 minus 3, 1. We said a raised to the power of 1 is the same as a, and that's your answer. As simple as that. Then we went to 4, this and this. Select 1, then the same thing, introduce your bracket sign. Minus 4, so plus times minus, and that was minus. This minus here, plus times minus gives us minus. So minus 8 minus 4. I said you owe your friend 8 naira, another one you owe 4 naira. 4, 8 differently. Okay, that means you are owing 12 naira in total. Because you are owing, it makes it minus. Each time you owe is subtraction. Alright, so minus 8 minus 4 gives us minus 12. So p raised to the power of minus 12. Then the fifth one, a raised to the power of 5 times b raised to the power of 4. Yeah, very simple task but confusing. Alright, very simple but confusing. And then I told you that each time you have same base, use the law. But different base, the law will not hold. And that's simply what we did here. You don't say, hey, 5 and 4. No, you don't say that. You don't say B 5 plus 4. You don't say that. You don't say AB 5 plus 4. No. Because of the singular reason, the law, alright, this. Okay, so A raised to the power of 5, B raised to the power of 4. No more, no less. Then come to the sixth example, which is the final one. Alright, 3, 7. Select them, pair them, then this and this, pair them. But here we said we cannot continue further here to use the law, simply because this and this are different days. So let them exist independently, let them stay alone. Alright, x is power of 4, y is power of minus 5. And that gives you your answer. Okay, and that's the one for you.